Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B kind of question. This is on topic 1, which is on moles and stoichiometry and all those calculation stuff. So for those of you who are familiar with this format, you will have known that 1, 2 and 3 are correct, that is option A. 1 and 2 are correct, that's option B. 2 and 3 are correct, option C. And only 1 is correct, is option D. So for this question, the sensible thing is to look for option number 2 first. But because I'm not rushing for time, I'm not in an exam. So what I'll be going through is I'll essentially go through all of the options where possible and trying to show it to you what are the concepts required to navigate through the options if you are not a very strategic person, all right? MCQs are a very good source of revision material for your theory content as well, because they are not just asking you specifically one thing. It could be assessing your knowledge on a couple of multiple concepts. Yeah, so you can always use your topical MCQs to gauge how good you are with your theory content, really. Okay, so this is saying that for complete combustion, 1 mole of the organic compound, you need 2.5 mole of molecular oxygen. So realistically speaking, we are just balancing equation. So that thing plus O2, complete combustion gives you CO2 and H2O. So there are 2 oxygen, there's 2 carbon there, so I need 2 carbon to give me 2 CO2. There's 2 hydrogen there, there's already 2 hydrogen there, so I don't want to add anymore. I need to maintain this as 1 mole. There it is. Okay, so the oxygen here, there's 4 oxygen and there's 1 oxygen, so altogether 4 plus 1, there are 5 oxygen atoms. I need 5 oxygen atoms, but I have molecular oxygen, so I use fraction. 5 over 2 times 2. I hope you can see there's 5 oxygen atom, and 5 over 2 is 5 divided by 2, that is 2.5 mole, so 2 is correct. Okay, if I check number 1 now, so C2H5OH, balancing equation again for combustion, CO2 plus H2O. You got 2 carbon there, so you will get 2 CO2. You got not 5 hydrogen, 5 plus 1, you got 6 hydrogen atoms. So to get to 6, you need 3 of the water. And now you have 4 oxygen plus 3 oxygen, so you have 7 oxygen atom. You do not put 7 over 2 here because there's 1 oxygen there. 7 minus 1, you need 3. Sorry, you need 6 oxygen atoms remaining, so you need 3 O2 molecule. So that is 3 O2 molecule, and you need 2.5 for your answer. And automatically we know 1 is incorrect. If 2 is correct and 1 is incorrect, 1 is incorrect, 1 is incorrect, so there can only be one answer, which is C. Okay, so that is without even checking number 3. Okay, but of course if you want, you can always practice balancing the equation with number 3 as well. Yeah, and it should always be right. Okay, but just in case you want to double check. Okay, CH3CHO, that is an aldehyde. You will learn more about it in organic functional group if you haven't. So CO2 plus H2O, so it's 2 carbon then, so 2 CO2, 3 plus 1, 4 hydrogen, so you need 2 H2O. Oxygen wise, you need 4 plus 2 oxygen, so 6 oxygen atom, minus 1, so you need 5 oxygen atom. So 5 over 2 times 2 again is 5 oxygen atoms from there. Okay, so 5 over 2 is again 2.5. So that's why without ever checking that, if I already check 2, if I check 1, then for sure 2 and 3 are correct. Okay, provided you haven't done any mistakes here. Next bit is a calculation thing again. I mean, obviously, because this is more calculation and stoichiometry topical questions. Yeah. So if I check number 2, they're saying that react completely. So the mole ratio here is 1 reacts with 2 mole. So check number 2. The relative atomic mass of zinc is 65.4 from your periodic table. Okay, and HCl is given as solution, so you have concentration. You have concentration and you have volume. Okay, so this is mole per dm cube. You have to convert that to dm cube. Yeah, otherwise when you multiply them together, the volume unit doesn't cancel out, okay? So the mole of zinc is to the mole of HCl. If I do the actual amount that reacts, so there will be 6.54 over 65.4. At the bottom will be 100 times 10 to the minus 3 times 1.00. This is the actual mole of zinc that reacts. This is the actual mole of HCl that reacts, okay? So 6.54 divided by 65.4, I got 0.1. At the bottom, I have 100 times 10 to the minus 3, convert to DMQ, times 1, I get 0.1. That gives me 1:1. But balance equation says the mole of zinc is to the mole of HCl is 1:2. 1 mole of zinc needs 2 mole of HCl. But here you have 1:1. So meaning to say 1 mole of zinc you need 2 mole of HCl. Here actually there's only 1 mole of HCl. Okay, that means your HCl is limiting. Your HCl is not in excess. Your zinc will be in excess. Alright. So that means this is a incorrect statement. And just by doing number 2, you can get the answer as number 1 straight away. Because as D straight away. Because if number 2 is wrong, that means only 1 must be correct. Okay. You can of course check for it. Do the same thing. Mole of zinc over mole of HCl. So 3.27 divided by 65.4. Divide by 0.050 mole. Then you will see that 0.1 divided by 0.05 will give you 1:2. Which is what you get from the balanced chemical equation. Alright. So 1 is correct. Without checking for number 3. Because number 2 is wrong. I can tell number 3 is wrong as well. Because there's only 1 potential answer. In this next question, it's a combustion analysis. So I've got a topical playlist under topic 1 on mole calculations. There will be like combustion analysis kind of question, alright? So you have J, you spark it with oxygen, and then you get CO2, and then you get N2. I can't balance this, okay? There's no information given. So that means I have to know what J is. If I check number 2 first, that is C2H3N. That will give me 2 CO2 because that's 2 carbon. There's 1 nitrogen there. So I don't want to add more number here because if I add a number here above 1, my numbers will be getting bigger for my balancing equation and calculation. So I only have 1 nitrogen atom. So half times 2 give me 1 nitrogen atom. In terms of there's hydrogen as well. So among the products, because there is hydrogen as well, so I have to get H2O because it's like combustion, right? And the only extra thing is the nitrogen from the end there, which means the complete combustion gives you CO2 and H2O. There's 3 hydrogen, so that's going to give me 3/2. 3/2 times 2 give you 3 hydrogen atom. How about the oxygen atom? So altogether you have 2 times 2, which is 4. 3/2 times 1, which is 3/2. So 4 plus 3/2, which is 1/2. I hope you can do your primary school maths. So 5 1/2, which is 11/2. Okay, so that is 11/2 oxygen atoms. Here is a molecule, so you need to 11/2 divided by 2. That's 11/2 times 1/2. That is 11/4 times, yeah. So that's 11/4 there. That looks complicated. What am I doing? Yeah, we really need a balance equation essentially. If we don't have a balance equation, we cannot do a comparison of combustion analysis. That's what I'm doing, okay? So what I'm going to do now is I will move this aside because I want to compare. I want to compare my my reacting ratio, okay? I change the color. Move this further aside. Okay, so what do we have? We have the volume at start, 10 cm3. You have an excess of oxygen, and then the volume at the end. So the H2 is just to balance the equation, but I don't think you need the oxygen anyway. So in hindsight, there's no need for me to balance that, but I still need to balance those. because it's from there. So I don't really need to balance that. I don't really need to balance that, but I need to balance that, and I need to balance that because those are gases at room temperature and pressure. This is liquid. So I think for the next one, if I have to check, I'll only need to balance this, basically with 1, and this and this. I don't care about this number because they're not going to help me. This is liquid and this is in excess, and I don't think I need it at all. Okay. So the one in pink is the volume, yeah. So what can I do now? The volume at the end is 20 cm of carbon dioxide, 5 cm of nitrogen. Is that true? So the volume ratio, so it's reacted and formed, it's going to be 10 is to 20 is to 5. The mole ratio, which is the same as the volume ratio, because we are dealing with gases, each of these will have the same molar volume of gas at that temperature and the room conditions. So divide by the simplest number, which is 5, that will give me 2. 20 over 5 will give me, hang on, no. I don't want, usually I want it to be the simplest number, but I want to check their mole ratio based on this equation where it's 1 here. So I want to make this into 1 in order to compare, yeah? So I'll divide by 10 to get 1. But because I divide that by 10, I have to divide the whole thing by 10 as well. Ooh, guess what? I get that. And that is 1 is to 2 is to half. 1 is to 2 is to half. This equation is I mean, it gives you that equivalence of the mole ratio for the gases produced. So that means that could be the identity of J. All right. Now I've got to check, because number 2 is correct. I got to check number 1. Like I said, I'm not going to balance the O2 and the H2O now. So I'll just quickly balance C2, H6, and 2. C2, H6, and 2. Let me just change that color so that it's very clear what I'm talking about. Like I said, I'm just going to concern myself with CO2, N2 plus H2O. I don't care about that. I care about 2 carbon. I care about 2 nitrogen, so it's just 1. Alright, so the volume at the start, I have, or actually, because all of this information are the same, right? Guess what? I could just use the same thing, the exact same thing. Because this volume, they are going to be the same because they were from the same information. So once I get the balance equation, I can just compare it to this, which I can just, compare really. Simplest mole ratio, which is that. Because the information is the same, right? So what is the point of you having to work it out again? Alright, so I probably need to move that a little bit there. Okay, because that is for carbon dioxide, that's for N2. Guess what? For 1 mole of it, you have 2 mole of CO2 and you have 1 mole of N2 because you got N2. You're supposed to have half based on the reacting ratio. So because of that, because of this being 1 and half, so this one is okay. 1, this one is okay. 2 and 2, but this one is not okay, doesn't match. So the formula for 1 is incorrect. Number 2 is correct. Number 1 is incorrect. You're left with 2 and 3 being the correct answer, which is C. Alright? Moving on to the next question. So, these kind of questions are really long, isn't it? Which statements about the quantity of substance are correct? So you have an excess of that, so you do not use an excess reactant in mole calculation because, well, it's not stoichiometric, right? It's not completely used up. So this is the one they're going to use because it's completely used up since the other thing is in excess. What's going to happen is, well, let's see. Okay, let's check number 2. So how much HCl actually reacts? So you use excess HCl, but how much actually neutralize completely? Okay, so the mole of the HCl is to the mole of the Na2CO3. From the balance equation is 2 is to 1. 2 mole of it reacts with 1 mole of it. On top is for that, below is for that. You could get it the other way around as long as you read correctly. Okay, so how much acid is required? So this is from the balance equation. Here is the actual amount. Okay, So the volume of HCl times the concentration of the HCl, which is 0.2. I forgot, the volume has to be converted because it's in cm cube, converted to dm cube by multiplying 10 to the minus 3 times 0.2 divided by 0.025. This is the actual mole of sodium carbonate. This is the actual mole of the HCl. This is from the balance equation. Okay, so the volume of HCl required is going to be 2 over 1 times 0.025 over 0.2 times 10 to the minus 3. I get 250, and the unit will be in cm cube because I converted to dm cube just now. So this is in cm cube times 10 to the minus 3, so the unit is in cm cube. So indeed, you need 250 cm cube to exactly neutralize the Na2CO3 based on the mole ratio. Okay, how about the carbon dioxide that's produced? Room temperature and pressure, the molar volume of a gas is 24,000 cm cube per mole. I could have used 24 dm cube per mole, but I choose not to because look at this. Okay, it all depends on your circumstances. Yeah, so the mole of CO2 is to the mole of Na2CO3. I'll scroll down a little bit, but 1 mole of CO2 is obtained from 1 mole of Na2CO3. That is from your balance equation. Your mole of sodium carbonate is 0.025. Your volume of CO2 in cm cube is divided by 24,000, which is the molar volume of the gas at room temperature and pressure. Okay, this is in cm cube, so I use the 24,000. So the volume of CO2, if I move that up, that's going to give me 0.25 equal to volume divided by 24,000, and then I move up to 24,000 again. So I've cut down 2 steps in one. Yeah, if you don't see it, do the calculation from scratch, and then you can see what I'm talking about. This is in cm cube, so 600 cm cube is indeed correct again. Now I have to check sodium chloride. The MR of NaCl based on the periodic table is 23.0 plus 35.5. That gives me 58.5. So the mole of NaCl is 2:1 then. So the mole of NaCl is to the mole of Na2CO3 is 2:1. Okay, and at the bottom there is 0.025 as usual. I want to find the mass of NaCl. I divide by the molar mass, which I calculated earlier, 58.5. So the mass of NaCl is going to be 2 over 1 times 0.025 times 58.5. That actually gave me 2.925 gram. And here is 1.46 gram. Let me just calculate because it's a bit dark, so I just want to double check. Yeah, I got 2.925 gram. So it's not 1.46, it's 2.925 if you do the calculation correctly, okay, based on the stoichiometry. So only 1 and 2 is correct, that is B. This question is about the percentage of atom by mass. We are talking about atom, percentage atom by mass. So if we look at starch, it is polymeric, but we look at the empirical formula, which is C6H10O5. So the percentage of carbon is going to be 6 times 12 carbon in empirical formula. Your MR, which is 12.0 times 6, plus 10 times 1.0 plus 5 times 16.0, you get 162.0, which your calculator of course show you as just 162. But anyway, it doesn't matter. It matters more when you're in a theory paper. And I forgot to multiply by 100%. Okay, so that gave me 44.4% to 3 sig fig. Number 2 is wrong. 40% carbon by mass. So that means only one is correct by default, provided I've done this correctly. Let me just double check. 12 times 6 plus 10 plus 16 times 5. Yep, 162. So 6 times 12 divided by 162. Yep, I got 44.4. In an exam setting, you have settled for D straight away. I'll just show you because I'm not in an exam setting. So I've got plenty of time. I'll just show you that that is actually the real answer, because you could be asked it in a theory paper. So 6 times 12, and your MR is 12 times 6 plus 12 plus 16 times 6, which is 180. So that divided by 180 times 100%. So you've got 12 for each carbon, you got 6 carbon divided by 180 times 100%, and that indeed give me 40% percentage of carbon. Okay, so that's why by checking number 2 already, you can tell there's only one answer when number 2 is incorrect. I'm just confirming it because I've got time. Alright, so this is the end of this 5 question series on this section B kind of question. It's a bit long for this topic 1 because it's all about calculation, more calculation. It might be a bit faster when we talk about trends, but my goal is not about time, whereas your goal in an exam towards the last 10 questions is more about time. Okay, I'll see you in the next video. If you find this useful, please subscribe to the channel. Please share them with your friends, your colleagues if you're a teacher, your class group chat, your juniors, your seniors, whoever else you think this content might be relevant for. Okay, thank you for watching.